Hi, I'm John. I'm going to be your instructor for DS6001, Practice and Applications of Data Science. I'm really excited about this course, and I hope you are too. Um, just a minute about my background. I'm faculty here at the School of Data Science. I teach this course residentially as well as online. My background is in political science, where I did mostly applied statistics to political data. When the School of Data Science launched here at the University of Virginia, I hopped over and started working here. It's really exciting, and I'm glad to be here, and I'm glad to be here online with all of you right now. So let's get started with our first module, how to get yourself unstuck. So you could see for every single one of these modules, we're going to have some slides that we're going to follow. These slides will be available to you as well if you want to follow along. So first, some notes about the course. This course is all about the data pipeline in Python. And by pipeline, we're talking about everything that needs to be done to data in order to do an analysis. Very, very rarely is data ever ready right out of the box to do machine learning or other cool things that you want to do with it. There was a article published in Forbes magazine. There's a link to it in our Jupyter notebook for this module that indicates that data scientists on average spend about 80% of their time collecting data and cleaning data. And that's 80% of your time, right? So the goal of this class is to reduce the amount of time you have to spend on these things by showing you the best way to collect data and clean data right off the bat so that you can get to the fun stuff more quickly. So easier, faster, less frustrating, more enjoyable for you. That's our goal. So this course is divided into 3 parts. First, how do we acquire data? How do we get the data? So first, we're going to talk about getting data from external files with flat tabular structures, like CSV files, for example. That's going to be Module 2. Then we'll talk about JSONs and how to get JSON files from APIs. And then we're going to talk about web scraping using Beautiful Soup. And then we'll talk about getting data from remote databases using SQL. Part 2 is how do we clean data? So we can clean data with SQL queries, which will be a continuation of our unit on SQL, and then with pandas. And then we're going to spend an entire module on the 2 most difficult tasks with pandas, and that's merging and reshaping a data frame. And then we're going to wrap up the course by talking about how do we explore data. Once we've done all of the work to get data clean and ready to go, then we can dig into it and begin to see what actually exists in that data frame. And so we're going to talk about how to do summary and descriptive statistics. We're going to talk about visualizations with Matplotlib and Seaborn. And we're going to wrap up the course with interactive visualizations using Plotly. So I'm very excited. Your grade in this class is going to be determined by the following things. First, reading quizzes. 1 reading quiz for every module, 10 points each, so 25% of your total grade. And these questions are going to be focused on the external readings, the textbooks and the articles. Second, lab assignments. They're worth 20 points each, or 50% of your grade. Every module is going to have 5 to 10 problems attached to it that challenge you to apply these skills to real-world data. Third, we have a channel on our Slack workspace for this class. I want you to post a minimum of 4 posts worth 15 points each for 12.5% of the grade. And each post is going to be a real-world example that you find of what we are talking about in this module. So when we're talking about APIs and some of the challenges with APIs, it'd be great if you could find an example of an API and post to our Slack channel. And then we could create a discussion there about the real-world challenges that we all face. And then finally, live discussion. So we'll be having a live discussion section every single week, and just some part of the grade is devoted to your participation in that. So that's the course, and please let me know if you have any questions about it. All of the course material and resources are either already accessible online, or they're chapters of an O'Reilly textbook, which is accessible for free to UVA students. So please do your best to access the readings for that use O'Reilly textbooks right away. See if you can access them. If not, let us know, and then we can get you access to those textbooks. Every module has a Jupyter Notebook attached to it. Hopefully you've seen Jupyter Notebooks by now, but if not, Jupyter Notebook is a way to display Python code, and it allows text to be written around that Python code to explain what's happening. So I'm using Jupyter Notebooks to illustrate how to do things in Python. The Jupyter Notebooks are the single most important resource in this class. These lectures are only going to cover a small part of what the Jupyter Notebooks will get into in detail. So please treat the Jupyter Notebooks as your primary resource. Okay, so that brings us to our first topic, and that is how to get yourself unstuck. This is probably the most important thing a data scientist can know, because being a great data scientist does not mean doing everything perfectly, despite the fact that some people will absolutely try and convey that. Oh, I'm a great data scientist, I do everything right. That is never true. Being a great data scientist means you make mistakes just as often as everybody else, but you know how to use the help resources to get to the right answer as quickly as possible. So typically 80% of the time is devoted to cleaning data, getting data. But if you're a great data scientist, maybe you get that number down to 60%, maybe 50%. That makes you a rock star. We are going to discuss various methods and resources that you have for finding help. And we're going to discuss the order in which you should employ each resource. Now, getting help is something that most people know how to do. But in our experience, we think that there is an efficient order. And the most important thing in this efficient order is don't Google first. Don't Google first. And by that I mean Googling is effective, but it's slow. When you Google a problem, it's going to lead you to lots of stuff, and it's hard to filter that stuff sometimes. Online, you're going to find information that is outdated or just plain wrong, and you have to adjudicate for yourself the quality of the information you find while Googling. Other methods are more likely to get you to the right answer quickly than Googling. Now, I'm not saying don't Google, I'm just saying don't Google first, okay? Okay, so there are many resources available to you. I suggest using the resources in the following order. First, read and understand Python errors. It's amazing to me how many people skip reading the errors it display when something's wrong with your code. And there are good reasons for skipping it, but there's also a methodology for reading the errors and using that to solve your problem. So we're going to talk about that first. Second, use the Python documentation. These are called doc strings, and we'll look at that. After using these internal sources of help, then we suggest Google, okay? Now, if you Google a problem, Google will almost always take you to Stack Overflow. There's a Stack Overflow page for so many things, but there is a method to both asking a question and answering a question on Stack Overflow, and we will talk about that. In addition to Stack Overflow, there's a Slack page called PySlackers. It's the Slack workspace for Python users the world over. And so on the Jupyter Notebook, there's instructions for how to get going with PySlackers. And then there are things like internet relay chat rooms with other Python users. There are instructions on the notebook of how to get going with that. And then there are various Python mailing lists as well. And you can see this website here, python.org/community, for more information about all of these resources.